Hi guys, I am Deves. You are watching Deves Don. In this video, we are going to see about acid, bases and salt. Let's get into this video. First of all, let's see about acids. Definition of acids is really simple. It goes like this. Any solution which releases H plus ions is called acid. There are two types of acids, strong acid and weak acid. Strong acids are the solutions which give out H plus ions very quickly. They are also called as mineral acids or inorganic acids. For example, hydrochloric acid, nitric acid and sulfuric acid. Weak acids are acids which does not release H plus ions quickly. They are also called as organic acids. For example, acetic acid, citric acid, lactic acid, etc. Now bases. Bases are exactly opposite of acids, but they have exactly same definition. It goes like this. Bases, which solution releases OH minus ions are called bases. There are two types of bases as well, strong base and weak base. Strong base are the bases which releases OH minus ions very quickly. For example, sodium hydroxide and potassium hydroxide. Weak bases are the bases which releases OH minus ions slowly. For example, ammonium hydroxide and ammonium chloride. Now let's see what happens when an acid or base react with a metal. Whenever acid or base reacts with a metal, it produces salt plus hydrogen. Now let's see, for example, hydrochloric acid plus zinc, it will give us zinc chloride plus hydrogen. Same way as with the base, sodium hydroxide plus zinc will give us sodium zinc oxide plus hydrogen. Now what happens when acid reacts with a metal carbonate or a metal hydrogen carbonate? Whenever acid reacts with a metal carbonate or a metal hydrogen carbonate, it produces salt plus water plus carbon dioxide. Now let's see some of the examples. First of all, let's see metal carbonate. For example, magnesium carbonate plus acid, sulfuric acid. Now magnesium carbonate plus sulfuric acid, it will give us magnesium sulfate plus water plus carbon dioxide. Liberate. Now let's see one metal hydrogen carbonate example. Now sodium hydrocarbonate plus HCl will give us sodium chloride plus water plus CO2, which will be liberating. Now what happens when an acid reacts with a base? Whenever an acid reacts with a base, it produces salt and water. An example for that is sulfuric acid plus potassium hydroxide, which will be giving us potassium sulfate plus water. Now what happens when acid or base react with water? First look at the case of acid. When acid reacts with water, it produces H plus ions and also the negative ions. For example, if you can take hydrochloric acid plus water, it produces the hydronium ions, which means H plus ions, along with the minus chlorine, which is minus. Now let's see what happens when acid react with the metal oxide. Whenever a metal oxide and acid react with each other, it produces salt and water. For example, hydrochloric acid reacting with magnesium oxide, it will be giving magnesium chloride plus H2O. Now what happens when acid or base react with non-metal oxide? Whenever acid or base react with a non-metal oxide, it produces salt plus water. For example, calcium hydroxide plus carbon dioxide will give us calcium carbonate plus water. Now what do all acids and bases have in common? This is a very easy thing to answer, because all the acids and base have equal number of ions present in them. Another thing common between them is the salt content. The salt content is equal between all the acids and bases, separating both the positive and the negative ions. Now when we look at the case of the base, The same thing happens when the water is added to base. The content in the base is exactly splitted into the positive ions and the negative ions. If you look at the example of magnesium hydroxide plus water, it will be giving magnesium plus ions and hydroxide minus ions. It separates it. So we can conclude that whenever water is added to a acid or base, it separates the ion within the content. It also apply for both acids and base. Now we have to know one thing, which is called dilution. Dilution is the process of adding water to a solution and increasing the solvent content of the solution, thus making it dilute. This process is called dilution, which is very important. How strong are acid or base solutions? As I already said, there are strong acids and weak acids, and like that strong bases and weak bases. How to find them? You may say litmus paper might be a good idea, but litmus paper is used to find whether the given solution is acid or base. To find how strong they are, we have to use the pH scale. pH scale gives you the accurate value of how strong is the acid or base or how weak it is. Now you take the, for example, if you take the distilled water, which is a pure water, the pH value of the distilled water is 7 because there are no minerals in it. It's absolutely neutral, so the pH value is 7. Then if you look at the normal tap water, the pH value will be around 7.5 something, because there are minerals present in this, so they may be slightly above 7 or slightly below according to the water we use. Like that, blood also has neutral. Blood is also neutral because the salt and the acid and the base content in the blood is quite stable, so it's not so acidic or so basic, it stays with the neutral. Now let's see the parts of the pH scale which represents the acid and bases. The first 1 to 6.9 are representing the acids, then 7 is neutral, that means 0, and the above 7.1 to the 14 are bases. Now from these, the first 1 to 3 is the category of strong acids. They are very strong, very dangerous to us. And the next is 3 to 6.9. In this category, the weak acids will be there. Weak acids like citric acid, etc. Then 7 is also known neutral. Mostly salt contents are here. And 7.1 to 9, in this range there are weak bases. After that there is 9 to 14, which consists of the strong bases. Now, importance of pH value in the regular life. First point we are going to see about that is plants and animals and pH values. Every soil must have some characters like acidic character or basic character in order to make a plant grow in that particular soil, because different type of plants have different type of characters which grow in different type of soils. So we have to first find out which type of plant will grow in that type of soil you have. For that we can check it in the laboratory before farming, and that's the main reason. Before farming, we have to check the soil and analyze it, and we have to know which crop it will be suitable to grow. Then there is animals. Animals are adapted to some kind of regions. Like camels should be in deserts because they are adapted to stay there. It is their area and the soil there suits them. And like polar bears in the Antarctic or Arctic areas, because that climate and the soil suits them. So the pH value of the soil will be varying and gives them the food they require. The food they get will be grown there. So animals also need pH value in their day-to-day life. pH value in our stomach. Now our digestive system secretes hydrochloric acid for digesting the food we eat. We all know that. When we not eating for a long time, the hydrochloric acid's concentration gets higher and it starts to burn the mucus layer of the stomach. It causes ulcer. So to avoid that, we are eating food regularly after every 4 hours. Now water is drank at because the water will be going there and diluting the hydrochloric acid. And the main point to remember at this point is it only dilutes the hydrochloric acid and does not make it lose any ions, because of water is a universal solvent. Now when there is a stomach burn, what should we do? We immediately want to take antacids, which are bases, and drink it to neutralize the acid present in our stomach. Like if we already seen that acid plus base will be reacting together and giving us salt plus water. The base will be going in and reacting with the acid, giving us the salt and the water, which easily goes down to the next step of digestion. So that is the pH values present in the digestion. Third one, pH value under tooth decay. We all know that there are bacteria present in the food that we eat. Some of those foods, the bacteria in those foods will be coming out through our mouth when digestion takes place, because they won't be able to survive in the hydrochloric acid. So they will be coming out through our mouth. You have to look that our saliva is made up of acid and our teeth is made up of calcium. Now toothpastes are mainly made up of bases. We'll know the reason in a while. Before that, these bacteria coming from the stomach reaches the mouth and they form a layer over the teeth by settling on it. It gives us the bad smell and the yellowish layer on the teeth. Now to prevent that, we are using pastes. We all know that acid plus base will be giving us salt and water. When the salivary acid and the toothpaste base react with each other, it produces salt. The salt removes the base bacteria from the teeth and cleans it and gives us the fresh look for us. Now fourth one, self-defense by animals and plants using the chemical warfare. Now imagine that a honeybee stings you and you will feel pain in the particular region where it stings you. Because that happen because the sting injects acid on your skin, which makes you feel irritated. Now to relieve from that, we have to just take a base and just spread it over there, apply it there, and after a few moments the pain will be getting stopped. This is because the acid is being reacted by base, thus forming salt and water, meaning that it neutralizes the pain. Now examples of some naturally occurring acids. First one is vinegar, which uses acetic acid. Orange uses citric acid. Lemon also uses citric acid. Tamarind uses tartaric acid. Tomato uses oxalic acid. Milk uses lactic acid. And ant sting uses formic acid. And the nettle plant uses methanol acid. Now pH value of salts. Mostly the pH value of salts is 7, because they are mostly neutralized. In some exceptional cases, their pH value will be slightly above 7 or slightly below 7, because when a strong acid reacts with a weak base, the salt formed will be the acidic salt, kind of acidic salt, and the pH value of that will be slightly below 7. When a strong base reacts with a weak acid, it will be like basic salt, which pH value will be slightly above 7. So those are some exceptional cases. Mostly salt's pH value is 7. Now let's see some of the important chemicals made out of salt. The first thing is sodium hydroxide. It is made by sodium chloride added with water will be giving us the sodium hydroxide plus chlorine plus water. This sodium hydroxide is solid in nature, it is soluble in water, and it is white in color. Some of its chemical reactions are sodium hydroxide with water H2O will be giving us a sodium plus ions and OH minus ions, and then sodium hydroxide plus HCl will be giving us sodium chloride plus water. Uses of sodium hydroxide. First one is sodium hydroxide is mainly used in the manufacture of soaps, rayons, cellophones, etc. And it is also used for petroleum refining and etching and re-greasing, etc. And in the concentrated form, it is used as a drain cleaner. Secondly, baking soda, it is also known as the calcium oxychloride. It can be prepared by adding a calcium hydroxide with chlorine, which gives us the calcium oxychloride along with water. This baking soda is pale yellow in color, it is soluble in water, and it is solid. Now some of the chemical reactions with the calcium oxychloride, that means baking soda, are baking soda plus sulfuric acid will give us calcium chloride plus calcium sulfate plus hydrochloric oxide. Then calcium oxychloride plus hydrochloric acids will give us calcium chloride plus water plus chlorine. Now some uses of baking soda. The first use is it is used as a disinfectant and germicide in sterilizing the water. It is used as a oxidizing agent in industries. It is used to make the wool unshrinkable and manufacture of chloroform. Thirdly, baking soda. Now how to prepare baking soda? It's quite easy. Now adding sodium chloride plus ammonia plus carbon dioxide plus water, we shall be giving us ammonium chloride plus baking soda. Now baking soda is solid, it is white in color, and it is also soluble in water. Now some uses of baking soda. Now it is used to make baking powder, which is a mixture of baking soda. Then it is used in making antacids, usually bases which used to make to control the stomach burn. Thirdly, it is used in fire extinguishers, which is soda acid fire extinguishers. Lastly, washing soda. Now how to prepare washing soda? It's very simple. Sodium carbonate plus 10 molecules of water will give you sodium carbonate and 10 molecules of water. Now why there is 10 molecules of water attached along with the molecular formula of washing soda? You may ask, because the formula of the sodium carbonate absorbs moisture from the air and gives itself the 10 water molecules. Even if you heat that, only 9 water molecules of that will be liberated, because the other 1 molecule is tightly bonded with the sodium carbonate. The washing powder is solid in nature, it is soluble in water, and it is white in color. Now some uses. It is used in the manufacture of glass, soap and paper industries, and it is also used for domestic cleaning purposes, and it is also used to make sodium compounds, and it is used for removing permanent hardness of water. Are the crystal salts really dry? Now for this question we are taking example as copper sulfate. In this copper sulfate, it is made up of crystallization process, but there is water of crystallization present in each and every molecular formula unit of copper sulfate. There are 5 water molecules in one formula unit of copper sulfate. This is because of the water of crystallization. With this case, we can easily compare it with the washing soda, which contains 10 water molecules. The other example for it is gypsum. Gypsum has 2 water molecules, and when it is heated in 373 Kelvin, it gives another material. Let's see about it. Plaster of Paris, also known as calcium sulfate hemihydrate, which is used by doctors for curing the cracks in the bone and the breaking of the bone by putting the plaster of Paris around it to place it correctly in that broken position. Now this formula is calcium sulfate of water molecule. Now we can obtain gypsum by adding another 1.5 molecule of water to it. So calcium sulfate plus half water molecule plus 1.5 water molecule will give us gypsum. Okay guys, that concludes the video. If you like this video, like the video and share the video. And for more videos like this, please subscribe to Devastone and wait for it. And if you want to give any feedback, please give it in the comment section. I'll be eager to watch that and rectify the mistakes I make. Until then, bye bye.